Hello National 5, in this video we are going to continue looking at computer systems, focusing in on computer structure. So from the point of view of the SQA, we need to be able to describe the parts of the processor, and we've already done that in the previous video. In this video we're going to look at memory locations with unique addresses, and in order to do that we need to look at RAM and ROM, and we're also going to look at buses and how buses work. So let's start off by just refreshing our knowledge of the 5-block model. So we've covered processor, and in this video we're covering main memory and the links between the processor and main memory. So main memory, we're going to gain an understanding of the main features of main memory, and you'll be able to identify RAM and the differences between it. So there are two types of main memory: random access memory and read-only memory. Now I could just sit here and chat you through it. However, I found this really good video that explains what RAM and ROM is in quite an interesting and fun way. So we're going to watch that now.
A computer is really just a collection of switches that can either be on or off. When we feed messages into this maze of switches, what we're doing is getting them to form various temporary patterns of ons and offs in the computer's memory. But we can't do this to all the switches because some of them have already been organized into preset patterns before the computer leaves the factory. These switches are stuck, and they consist of permanent instructions on how to load programs, how to print things on the screen, and so on. The computer can read this left half of its memory, but it can't write on it. It can't change it. It is therefore called read-only memory, or ROM. But the computer can, in a sense, write on the other half of its memory. This half is called random access memory, or RAM. Because the computer can write temporary messages anywhere it likes here, it has random access to this part of its memory. But if you switch the computer off and then on, the messages in its random access memory disappear. The loose switches are scrambled once again, whereas the instructions in the read-only memory stay as before. The switches are still stuck in the same position. Of course, you don't necessarily have to program messages into RAM yourself. You can load a ready-made program full of messages into it from a cassette or a disk. You can take the cassette or disk away and the messages will remain. But naturally, if you turn the computer off and then on, once again the messages will disappear. But at least you've still got the originals on your cassette or floppy disk. So ROM is read-only memory, and it's permanent. It never forgets. Whereas RAM is both read and write memory, and it's temporary. It forgets at the flick of a switch.
So that is what RAM and ROM are. Random access memory is your working memory that the computer uses on a day-to-day basis, and your ROM, or your read-only memory, is really the memory the computer requires to boot up and launch and tell it to where it needs to go to find the operating system. Let's now have a look at buses. So buses, we're going to gain an understanding of the different buses that link the CPU and main memory together, and we'll be able to identify and describe the purpose of the control, address, and data buses. So buses are the lines that connect the processor and main memory together. They transfer different things between main memory and processor. There are three different types of buses. We have got the control bus, address bus, and data bus. So the control bus carries the signal from the processor to main memory, telling the main memory, this is what's happening, this is what I'm doing. The address bus carries from the processor to main memory where in main memory, what location in main memory we want to go to. And then the data bus is a bidirectional bus. It's bidirectional because we can send data to main memory from the processor, and we can receive data from main memory into the processor. So the data bus is bidirectional, the control bus and the address bus are unidirectional because the information only goes from the processor to main memory. So let's have a look at a couple of animations that can help clarify this up. So we're going to have a look at how we read data from main memory. You'll see on the left-hand side, we have got a simplified model of main memory. We've got different locations, and each of those locations have a unique address, and that's how main memory is arranged. So onto the control bus is the command read. Okay, so the memory knows I'm being read from. The address bus is told where it needs to look in main memory, and that information is transferred over to main memory. We then go to location 2 and load the piece of data from location 2 onto the data bus, and then it goes to the processor into the register. So it goes onto the data bus and into the register. So that's how you read information or data from main memory. If we look at now how we write data to main memory, so it's a similar process. Onto the data bus, it's told where it's going. Onto the control bus, the command write is given, and then the piece of data that we're writing to main memory is put on. All that goes over to the memory, and then the piece of information goes into the memory location specified. So in those two animations there, you can see how the data bus works and the fact that it's unidirectional. So in this video, I've very quickly gone through the different types of main memory, RAM and ROM, the different types of buses, the address bus, the control bus and the data bus, and the fact that within main memory, every memory location has a unique address.